Hello, how are you? Hello, can you hear me?
Yeah,
Yeah.
How are you guys doing?
good.
Some of you who requested for who qualified for makeup and requested for it, I'm sure you checked your emails. I sent you the makeup, and those are requested for the. I mean, you check your email, you see my response, and so you can start working on those. Okay. Um, Today I couldn't make it to the campus. Again, anyway, this week we'll still be working on. What's my test of hypothesis? That's where we started. I want to show you the announcement for the week first. Now remember that when we meet in the campus, I will be able to give you the. I mean, those of you who haven't yet send me their project group. I wanted to do it today, but since I was not in the campus, I couldn't make it to the campus today. That means maybe on Thursday. So I already have two people that have their group members approved. But for those of you who are not, we'll see on Thursday. That will be taken care of. So you can see your members or your group and introduce yourself to each other. And then you can begin the project. Remember, we don't have much time left. So now, this week we have homework 1 due on Sunday. Test 2 due on Sunday as well. Semester group project due on December 1. So the earlier we can start the project, the better for you. So I will try. I mean, I wanted to. If I can't do it today because we're not. I don't. You see me here, but everybody don't see each other here. But in the classroom, we see everybody. I will give you your group names of people in your group. You can see each other, introduce yourself, and so on and so forth. So just writing this, marking this person present. Okay, let's begin. We're still on chapter 9. We do only the test or hypothesis for a single population. Okay. For test or hypothesis for the mean, for one sample, yeah. So I'm sure you can see this. Okay. Yeah, this. Canberra. So this is it on the screen. I introduced you last week to it. We did some, we even do a classwork on how to state hypothesis. But now, let us do the actual work of testing hypothesis. Okay. Now, we start with the traditional method. Today, we cover traditional method today. On Thursday, we covered p-value method. So we start with the z-test for the mean. The working rule says, state the hypothesis and identify your claim. Find the critical values from the appropriate table. Compute the test value. Make the decision to reject or not to reject no hypothesis. Then, of course, summarize your results. So you can see how the process goes. Now, how do you make the decision to reject or not reject? The criteria is this: for traditional method, you reject null hypothesis if and only if your answer, which is the calculated z-value, is equal to or is greater than the critical value. That's how you make it. So if your answer is bigger than the critical value, you reject. If it's not, you don't reject. I mean, if your answer is equal to or larger than the critical value, reject. And this is the test statistic. Z equals x bar minus mean divided by standard deviation over root n. You know that we have come across use this formula before when we are doing normal distributions, central limit theorem. So I'm sure you're familiar with this. Where x bar is the sample mean, mu is the population mean, delta is the population standard deviation, and n is the sample size. So that we have with this information that will help you to present your summary statistics, you can be able to test my hypothesis, whether it is true or not. Okay, let's start with one example. Actually, two examples. A researcher reports that's number 8, the average annual salary of assistant professors in the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, test the claim that assistant professors earn more than 42,000 a year in 1997. The standard deviation of the population is 5,230. Okay? So now let's get the summary statistics ready. The first thing you do is, of course, is to state the hypothesis you are testing. Okay? We're going to have HO and H1. I think I'm going to make these things to be 18, so that we can see it very well. Yeah, I'm going to make it 18. Okay. So now, HO, now it says that here that the researchers report that the average annual salary of assistant professors in the year 1997 is more than. So you can see the keyword here. The average annual, this is average. That tells you that it is mean. Average annual salary. That's the first keyword you're going to take note of. Okay. Is more than another keyword right there. So that means more than means greater than. And as you know, okay, you can, yeah, this is the third one. It's still the same thing. It said, test the claim that the annual salary that the assistant professors earned more than, okay, more than, see, 42,000. So you can see that those keywords. So more than means greater than. Like I told you last week, you can only use greater than in for alternative hypothesis, the symbol greater than. You cannot use it for my hypothesis. So you have mean. Average means mean. Mean, okay, is greater than, say, 42,000. 42,000, and that is their claim. Okay. Now the null hypothesis, sorry, you can use greater than only in the alternative hypothesis. Now the alternative hypothesis and the null hypothesis, they say things that are opposite to each other. Now the alternative says greater than, which means that the null will be less than. However, the problem that we cannot use less than symbol in the null hypothesis. So you can only use less than or equal to symbol. So you're gonna put less than or equal to $42,000. Now the alpha, which is the significance level they are using, is 0.05. Okay, so I'm gonna put right here. Alpha is 0.05, so that we can now get our critical value. So that we have critical value. The critical value. Now look at this. This is greater than. So you can see that it is pointing on the right side, which means that it is a right tail test. Okay, a right tail test. A right tailed, excuse me, tailed test. So the critical value. You know, when we did critical value, when we are doing a confidence interval, confidence interval involve two sides, and we're using Z alpha over 2 because they have two sides. But this one is right tail, only one side. So you're going to do right only Z alpha, which means that the formula we use for critical value and to get critical value for confidence interval will not work for when the test is one side, whether it's left side or right side. But for two-tailed test, which is two sides, you can use the same formula that we use for confidence interval. But for this one, it's right there, only one side. You can use that. So now let's to be able to get it, I'm gonna draw the chart here. Okay. So you have excuse me, sorry, my mistake. So you have whenever it's on the tail, we have 0 here, Z alpha, okay? The alpha, which we are about to get now. So I'm going to make sure I've seen all this. Yeah, you're seeing it, okay. So I'm going to insert, draw the curve, normal distribution curve here. Okay. Okay, that'll give us. Okay. Now we have this all the way back here. Move it a little bit. You can be at the center and bring this one back in. If you see, I'm sure you still remember this curve. Now, the center line will be here. And then Z alpha, which we're about to find the critical value. So anything that is in the critical value, we reject it. Okay, if we fall in this, if it equal to the critical value or greater than it, we reject no hypothesis. Okay. Now let's get the alpha. Remember when we are doing normal distribution, I remember I explained to you with the procedure chart that if your answer is in any of the tails, remember this is half of this is 0.5, the other half is 0.5. So if the answer is in any of the tails, you subtract from 0.5 to get this small space. The whole of this is 0.5. To get this small space, subtract this from 0.5. So 0.5 minus the alpha they give us is alpha of 0.05, 0.05, which we can get from the calculator. 0.5. Okay, where is that calculator? Let me see. Okay, just 1 minute. I'm gonna pull it out here. Okay. So 0.5 minus 0.05 is 0.4500. Actually 0.45, but because that table have four figures, you have 0.45, but you have 4 digits in that table, which we'll be using. So put these two placeholders. Now we look at for this on the table of normal distribution. Now remember I mentioned that there are 2 types of this table. There's one of them that is you see in your homework page in my lab and master. That one is cumulative type. I recommend that you use this one and follow the method I'm showing you. If you're using that type, you have to follow a different method if you know how to do it. But to be on the safe side, use this, follow this method, and you should be fine. You will be fine. So look for 0.4500 inside the table. 4500. See, I have 4495 and 4505. Okay, let's see. 4495. I see right there. You should have, I didn't see 0.4500 exactly, but I saw two numbers that are closest to it, this and that. Okay, I choose the one that is closest. And if both of them are equally close, we choose the bigger one. So let's check this one. See if it's closest. 449. So ignoring the decimal point, I have 4500 minus 4495 is 5 points away. Okay, let's check the other number, which is this one, 4505. 4505 minus 4500 is also 5 points away. So the both of them are equally close to 4500. So in that case, you use the bigger number. This is this, which is the bigger of the two numbers. Okay. This one, which is this one here. Okay. You follow it to the left, 1.6. Follow it up, 5. So it's 1.65. So that the critical say 1.65. So that made the critical value to be 1.65. Okay, from the table, 1.65. So now that means this in here is going to be 1.65. So I'm going to erase this part. So you have 1.65. So if your answer is equal to this or more than that, you reject null hypothesis. Otherwise, you don't reject. Now we are ready to do the work now. So let's put our summary statistics. Okay, and here, look at the question again. It said that a research report that the average annual salary of assistant professors in 1997 is more than 42,000. So mean, okay, population mean equals 42,000. Excuse me. I like to have this thing to be, okay? Okay, let me finish then. Now, to test this claim, okay, a sample of 30 assistant professors were selected, and they have an average salary of 43,260. N is 30 assistant professors. N equals 30 assistant professors. Excuse me. Just 1 minute. Somebody knocked at my door. Just 1 minute. Sorry about that. Somebody knocked at my door. So anyway, so out of these 30 assistant professors, it said that the average salary is 43,260. Now, somebody might say, oh, okay, is 43,260 is already bigger than 42,000 that they claim. They claim that it's bigger than that. And 43,260 of these 30 assistant professors were bigger. So why do the test? of course, we have to do the test because these 30 assistant professors is only 30 of them, and we don't know how the sample was selected. We don't know whether they are selected from the same college or the same university. So we don't know. We have hundreds of thousands of assistant professors. We have, let's say, thousands of them in America. Plus now they give us the population standard deviation too. So we cannot judge it based on only 30 assistant professors that we don't know how they were selected. So we still have to run the test. So that means the sample mean is 43,260. So we don't have the character for sample mean here. So I'm going to get it from the other workbook. Let me write this down. And the sample mean X bar. Let me write the first one. Mean is 42,000. Sample size is 30. Sample mean X bar is, according to the equation, is 43,260. So I'm going to get the character for the X bar from the other workbook. So we have X bar, okay. X bar maybe okay, I got it from here. X bar will be equals, okay. I'll try it. I'll do it a different way next time. I think I figure out something. X bar is 43,260. Okay. All right. X bar is 43,260. Then they say that the standard deviation is for the population. They say that the standard deviation of the population is 5,230. Delta is 5,230. Yeah. So the standard deviation is delta. Okay. Delta equals 5,230. So the character change. Let me adjust it again. Delta. Okay, so that's okay. So now we have everything 5,230. Now we're going to plug this into this formula here to run the test. Okay, plug the formula here. So I'm gonna let's write all this down. I have it. I want you to take note of this. Mu 42,000, sample size n is 30, X bar is 43,260, and standard deviation is 5,230. So we're gonna use this to run the test. Okay. So let us run the test. I'll have Z, since we have to get the formula from this workbook. The Z is equal to the X bar, okay, minus the mean divided by the standard deviation of delta over the square root of n. Okay. So once again, refreshing your memory on this from the other workbook. What these values are: sample mean mu is 42,000, n is 30, X bar is 43,260, and standard deviation is 5,230. So let's go and plug those things into the formula to get the answer. So you have sample mean of 43,000, okay, 260, okay, population mean of 42,000, the standard deviation of 5,000, 230 over the square root of n. And we start, right? So that we can now put all this into the our calculator. Let me write this down. 43,260 minus 42,000 over 5,230 square root of 30. So let us go and put this on the calculator, get our answer. This is what we call running the test. Okay. So you got 43,260 minus 42,000 divided by the standard deviation of 5230 over the square root of 30. So we got 1.32, actually 1.32 approximate, approximate value. I'm sure you can see this. It's 1.31956103, which is approximate 1.32. Let me write it down. 1.32. Okay. Now, let's go and put it on our answer then. You got 1.32. I'm gonna copy this and paste it into our main workbook so we can make our conclusion. We'll compare the result and make a conclusion. Okay. 1.32. See, this is critical value 1.65. So 1.32 should be inside it. Remember that let me refresh your memory. That here, okay, we reject if it fall in the critical region. So that okay, we have to reject if it fall here. If it's equal to the is it equal to the okay equal to the 1.65 or for in any of this place you reject, but other than that you don't reject, so that the unshaded region like here that is not shaded, okay, if you fall inside here you accept, okay, you don't reject. So now this is our answer. Let's make our conclusion. Having shown you that, let us make our conclusion. I hope you are ready. Conclusion. Oh, sorry, not conclusion, decision. Decision first. Okay. Our decision says the critical value is, say critical value is 1.65. Critical value is Z alpha. Z alpha, okay, equals, we get it at 1.65. 1.65. Okay. Now, calculated value, that's our answer. Calculated Z equals 1.32. So what will our decision be? Remember the criteria. It says you reject null hypothesis if and only if the calculated value is equal to or exceed the critical value. So our answer actually is it say 1.35 falls in the acceptance region. So that means it is less than the critical value. Okay. Do not reject. Do not reject HO because the calculated value Z equals 1.32 is less than the critical value of 1.65. So if it's equal to it or more, you reject. But here it's not, so you don't reject. So now that means you're about to make a decision, final decision. So we don't reject. So our hypothesis is that he say don't reject this. That means this claim is not correct. Since we are not rejecting this, that means we are accepting it. That means this one is not correct, the claim. So the claim, so there is not enough evidence to support the claim. That's what he said. Since we rejected it, we don't reject no hypothesis. So the claim is in the alternative hypothesis, this claim. So you can say that we can there is insufficient evidence to support the claim that the assistant professors make earn more than 42,000 in the year 1997. So we rejected the we do not reject the null hypothesis that we don't reject. That means this claim is not correct. So that's why you concluded that there's not enough evidence to support the claim. Now, any question on this class? Any question? Good. So let's do another one when we have two tails. Okay, I will start with this one. This space will not be enough for this, so we'll move it down to the next space. It says here, the medical rehabilitation education foundation report that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and find that the average cost of their rehabilitation is $25,226. The standard deviation of the population is 3,251. At alpha 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from 24,000 to 672? So this is the claim was that the average cost. Give me 1 minute. Let me check something here. Just 1 minute. Okay, I got a bit here. Okay. Anyway, the Medical Rehabilitation Education Foundation, their claim was that the average cost of rehabilitation is 24,672. So let's look at the keywords there. They claim that the average cost of rehabilitation is average cost is the first keyword. That means you know that you're doing average. That's for the mean. Is, of course, is means equal sign. Okay. Now, okay, it is to see if the average cost is different. So now this is the main keyword right there. So let me look at our solution. Okay. We'll start by making this H1 H1 HO and then H1. Now the claim was that average cost of rehabilitation is 24,672. So now we have HO mean equals, okay, 24,672. That's what the hospital was claiming. And this one, H1 is the opposite, which means it's different. Mean is different. That means we don't know whether it's less than or greater than, but just say different. So we're gonna use not equal to 24,672. And say our alpha is 0.01. So I'm gonna be some 0.01. Okay. 0.01. So that we can find the critical value. Now, this is two-tailed test. It says not it says different. That means it can be less than or it can be greater than. So it's a two-tailed test. A two-tailed test. Okay. So that our critical value, we're gonna use the same formula we use for confidence interval, the shortcut formula. Our critical value this time gonna be Z alpha over 2. Okay. Z alpha over 2, since it's gonna be two sides equal. So I'm going to excuse me, let me adjust this. So you got P over 200. That P is the say if it's they say alpha is 0.01, that means you are 99% confident of not committing type 1 error. So your chance of being right is 1%. Anyway, let me make all this to be 18. Font size 18. So this, percentage is 1 over 100, is over 100, but since this is going to be two sides, that's why I make 2 over 100. So we're going to have it over 200. So have 99. Why do I get 99? Because it says alpha 0.01. That means your chance of committing type 1 error is 1%. So your chance of not committing it is 99%. So 99 over 200. So on our calculator, we have that 99 divided by 200. 0.495. Okay. So 0.495. 0.495. Since this number on those tables are 4 digits, I'm going to use this placer to make it completely 4 digits. Now I'm going to look at this for this, the table of normal distribution. Have let me look at it again. We got 0.4950. 0.4950. Okay. If you don't find it exactly, we use the number that is closest to it. 0.4950. 49. I got 4951. Okay. You follow it to the left. 2.58. Because I have 4949 and 4951. They're equally close. See? 4949 here. Okay. And 4951. They're equally close. So I use the bigger one. 2.58. So 4951 is the closest number to 4950. So 2.58. So I'm going to put 2.58 right here. 2.58. Critical value. And you can see how the let me show you how this gonna be on in the chart. On the left side, because it can be either side. It is 2.58. You have 0, positive 2.58. Now you can now insert your bell curve. You're gonna be like from here. All right, say okay. There's some adjustment here. So you gotta put center line. Okay, I put this here on the left side. On the right side, I have this. This should be the same. Forgive my the how get legible. So I'm gonna have this if you fall any of this shaded area, you reject. Or any of this shaded area, you reject it if you fall in any of them. Okay. Yeah. Now we have our critical value. Now let's write down our summary statistics. So that the mean is 42,000, 24,000, 672. Now sample mean, to test the claim, they selected a sample of 35 stroke victims. So N is 35. Oh, excuse me. N equals 35. Out of these stroke victims, let me move this down so we can have a clear vision. Out of this, so that the sample mean of is 25,235. Let me write them down first. So we can now continue from that. You have some population mean is 24,672. Okay. Now, which is right here. N is 35. Out of these 35 stroke victims, the 35 of them selected have an average cost of rehabilitation of 25,000. That means X bar 25,226. Write that right here. X bar. I'll write it up here. X. Oh, excuse me. X. Okay. X gotta be X bar. So I'm gonna put the bar on top of it. I figure out an easy way to do this. X bar equals 25,226. Right? Then the standard deviation of the population is 3,251. Delta is 3,251. Okay. Delta. Okay. Delta equals 3,251. 3,251. Yes, that's what it is. So let's just run the test. So again, I correct this formula. This character here, delta. Now, to run this test, we're gonna go to the other workbook and put it in. So I'm going to erase some of these things here. So we can, okay, put them in. Z equals, say, sample mean minus population mean. Sample mean is 25,226. Population mean is 24,672. Okay, divided by standard deviation of 3,251 over the square root of 35 stroke victims. So let us go and plug this into the calculator, see what it gives us. Let me write down Z equals 25,226 minus 24,672 over the standard deviation of 3,251 over the square root of 35. So let's go and put all this into the calculator. Get the result of our test. Okay. And then come back and put the answer, make our decision. So we got 25,226 minus 24,672 divided by standard deviation of 3,251 over square root of 35. 1.00815386. That means 1.01. 1.01. Okay. So 1.01, we're going to put it on that answer and then copy it to the main workbook. 1.01. So I copy this, then paste it into our main workbook. The result that's the result of our test. So now we can now make a decision. Decision. Okay. Okay. Our decision. You can see that our answer 1.014 inside the acceptance region. Anyway, it wasn't bigger than critical value. So critical value Z alpha over 2 equals, we got it as, it can be in other side. Just since the answer is positive, we can only consider the positive side. 2.58. Sorry, 2.58. It should be plus or minus 2.58. So if you have a negative answer, it goes on the negative side. 2.58. 2.8. Then, okay, our calculated value, calculated Z, that's our answer, is, we get the answer 1.01. Again, our answer is smaller, it is smaller than the critical value. We don't reject. Do not reject HO because the calculated Z is less than the critical value of 2.58. See, so we don't reject. Which means that we are not rejecting the claim. That means the claim is, see, the claim is, this time around, the claim is on the null hypothesis. So we are not rejecting it. That means this one is not correct. The alternative is not correct. So in that case, our decision will be, our conclusion. Okay. There is enough evidence. There is enough evidence to support the claim that, okay, and the average cost is this. And the average cost of rehabilitation, that's the average cost of rehabilitation for stroke victims is 4,000 24,672 Any question on this? Any question, guys? Hello? Any question for me?
No, there's no question.
Oh, good.
No, there's no questions.
Excellent, excellent. Now, when we meet on Thursday in the classroom, we'll do the dollar method, which is the p-value method. Like I said, those of you who have attendance up to 70%, that those that send me the email, I have responded to them and I have given them their makeup classwork, makeup assignments. So please read the email and follow the direction. If you're here, attendance is up to 70, you can still send it today. Now, if your attendance is very close, like if you have a 68%, now that means by Thursday, by Friday, it should be match up to 70. Then you can also request. Now, if your attendance is still far away, you still have from now till 10th of December to make it, push it up, and then you can request. Okay? Hello? Now, don't go away. I want to take down your names. I got a big girl here.
Wait 1 second. I got a question.
Yes, sir. Go ahead.
Yeah, so the first test we had like a little review. We had a review.
Yeah, there's a review for it.
It's a review for this test too?
No, this one is whatever we that's why I give it to make it to the video. I have the video that will answer that we can use for the review. You just watch my videos on each I can, if you want, I can make a collection of videos, right? That
Right.
you can watch that can help you to, when you are solving this question, you can click on the video for, let's say that they ask for test of hypothesis, right? You can watch
Right.
the video for test of hypothesis. You know what I mean?
Yeah, all right.
Yeah.
All right.
So I'm
Thank
gonna do that, try and get that done for you. I'll put it on the announcement. Okay?
All right, thank you.
You're welcome. So I have Grace here. I have Grace already. Gillison, I got Gillison here. Campbell, I have Campbell. Miss Campbell's here. 8. I already checked 8, I believe. Yeah, I checked 8 already. Iana. Who's Iana? Okay. Yeah, okay, Iana Green. She's here. I got Jody. I got Jody already. Yeah, I got him already. Jemiah Allen. I got Jemiah Allen. John James. Okay. Michaela. Got Michaela. I got Maria already, right? Yeah, I got Maria already. Mercy. I got Miss Mercy. Mercy. More. Miss Carla Moore. Okay. I got her. I got La Rose. Yeah, okay, La Rose. I got Miss La Rose. Olivia Hogan. Got her.
Wait, Miss LaRose is here.
Yeah, I checked her name already. Then Watson. Okay.
I'm here.
Then I got Wright, Miss Wright, she's here. I got who else? Tejia Brown. Yeah, I got Tejia Brown already, right? Yep. Enoch. Okay, Enoch. Yes, Enoch. Adams. I got Adams. Yep, I think I get everybody. So I see you guys on Thursday. Hopefully, I'll make it on Thursday. But I'm just.
Did you get me
in
as
fact, I'm
well?
gonna be there, unless there is a bad weather. But I'm still gonna be there on Thursday. Okay.
Excuse me, did you get Kyla Reed?
Read. Yeah, I got you already. Yeah, I got you already.
Did you get
Thank
Michaela
you.
George?
Huh? Michaela Brown, right?
Michaela George.
Michaela
Mhm.
Moore, right?
No, George.
Yeah, I got you.
Okay, thank you.
You're welcome. So I see you guys. You to see you guys on Thursday. Okay.
Can I ask you a question?
Okay, see you.
Yes, ma'am. Go ahead.
I just wanted to ask because I wanted to know if you were like fully done grading everything or not yet.
It's only one assignment that I left. Two that I have not been graded yet for now. Only two.
Okay.
So I'm gonna grade the two of them this week.
Okay. I was just asking because I had classwork 8. I had submitted it, but it was never graded. So on my side, it just says
Okay.
a dash out of 100 because it's not gonna say 0 because it hasn't been graded yet. But I did
Yeah,
submit.
I'm gonna grade it. No worries.
Okay, thank you so much.
You're welcome.
Have a great day, Professor.
You too.
Hey, Professor.